Hello everyone, this is a video lecture for pre-calculus, doing section 7.6, vectors. Now, vectors are going to be super important to you in Calculus 3, in physics, in engineering, all kind of things. This is like so important to you, and so please pay attention. At the same time, the section here in my math lab is very long. There's a lot of homework problems. They're also all very short and easy, but it's still tedious. The concepts though are actually fun. Okay, vector v is equal to x and y. This is very similar to just saying that we have like a point x comma y. And so let me show you the difference between a point and a vector. Here's your point, and here's a vector. Okay, you're going. It's basically you're going out until that point from the origin. That's a vector. So this is the vector. Okay. So the math is all going to be very similar to what we've already done. Regardless of whatever they ask, you could pretty much figure out what's going on, I'm sure. Now, my math lab does not use the little arrow thing on the top. That's just because I can't do what they do, and they bold it. They have bold V. So every time you see bold V or U or W or whatever, the bold means it's a vector. I'm going to put a little arrow thing on the top instead. Now, they do use alligators, these little inequality symbol thingies. I just call them alligators, but they're just vector symbols. They're to compare the difference between a point that uses parentheses. Okay, so points use parentheses, vectors use the alligators. Another way you can do vectors is the component form, which is going to be I and J. Oops. So, oh, no. Okay, there we go. I and J components. Now, again, let's talk. So this is an x value, this is a y value. That I is not the square root of -1 anymore. Nope. It means I. And that's a J. And the one after that, if you had it, would be a K. Go figure. Notice that my components have little carrots, little hats on them. This just indicates that they are a component, okay? They're not actually the square root of -1 and all that stuff. Okay, so now that you got some notation down, they're going to also ask for something often. It's double lines with a vector, so double absolute value line thingies. Often, that's just my math lab. Moving forward, you'll also see it with the singles. So you'll see doubles or you'll see singles. Either way, it's the Pythagorean theorem. Just like we had last time, being the modulus or the magnitude is what this one's called. The magnitude. So doubles or singles, either way is fine. I used to be a doubles fan, and then I went to singles, and it doesn't matter. They're all fine. Okay? So they're going to ask for that a lot, and we're going to have to give it. Okay, let's start doing some actual problems. So I've got vector v is equal to -4i minus 3j, and they say graph it and find the magnitude. Well, -4, -3, yawn. But again, the vector is the arrow, so make sure you don't like put a dot out there and that's it. It's a vector. It's an arrow. And they have the double lines. Again, it could be the single line. Yawn. 4 squared plus 3 squared. That's a special triangle. The answer is 5. Yeah, okay. So how do we create vectors from points? And not just 1 point, but 2 points. So here this problem has a P1, -7, 9. And then we have a P2, which would be -5, 3. And the vector v is supposed to be going from P1 to P2. I don't know if they say that or not, but it's a vector from P1 to P2. So I'm going to draw this just so that you're understanding exactly what's going on, but you don't need to draw it to get the answer. Negative 7 comma 9 is somewhere up here. And then we have negative 5 comma 3 is somewhere like right here. And they're saying you're going from P1 to P2, and that's my vector right there. Now notice that my vector is not from the origin, right? And that's okay, but when I actually get a vector v, it's going to be as if it were from the origin, okay? So like copy, paste, okay? That's kind of what's going to go on. Well, how do we find this vector? How do we know how far we're going and all that stuff? Very simple formula. Each vector, when it's dealing with points, the formula is that it's terminal minus initial. Terminal minus initial. And like later, I'll just do terminal minus initial. I do that very often in Calculus 3 because we just do it so much. Okay, so terminal is actually the second point. And then the initial point, I keep doing that, is this one here. And when you're subtracting two vectors, it's just as you probably guessed. Your x component with your x component makes your x component. Oh, whoa. Tiny little addendum, right? Don't I have to distribute my negative? So it's a positive 2. And then I have my y component. My y component, that's now a negative 9, so negative 6. There we go. Now, let me graph that for you so that you can see it. And I want to compare with the graph that we already had. Some kind of like just, what would it look like? So 2, 1, 2, 3, 4, 5, 6. I don't know. Those look pretty similar to me. We did it! And it's wrong. What? Yeah, they want it in the IJ format. Now, how are you going to type that into MyMathLab? I have a note here. It says, just type I and J. MyMathLab understands. I'm serious. So there it is. So you're going to type 2I minus 6J, and it's going to say, great job. It just understands right now that you're in this section, you use an I and a J, it's supposed to be the components, okay? So good times. Okay, so I got 6I, 3J. This component form is really slow. The alligators are always better for speed. But the components have their strengths. There's some particular situations and formulas where the component method is much better. Here, not so much. So they're saying u plus v is equal to what? Okay, well, it's just as you imagined. I have two vectors. I'm supposed to add them. So I've got a 6, negative 3, plus sign. I got a negative 7, 9. And then I'm going to just add them together. So 6 plus a negative 7 is a negative 1. Negative 3 and the 9 makes a positive 6. Yay! So they, of course, want it in component method for right now. Whatever. Did they always want component method? Looking ahead? Mostly. I still think the alligators are better. But what do I know? I'm just a math teacher. Okay, I'm sorry. Oof, that just kind of burst out there. So we got u is equal to 6, negative 7. And we got v is equal to negative 7, 5. And now they want to subtract them. Oh, my goodness. Are you seeing that, like here? So subtract, again, when you're putting a minus sign, you have to distribute that to both of them. So it's actually going to be 11 and a negative 12. Are you seeing, oh, no, it's not 11. I'm sorry, that's 13. Are you seeing that this is like easy? And I know I mess up things like 11 should be a 13. I get it. But the math is not hard. It's just It takes a lot of time to draw. It takes a lot of time. I sure hope you're 2 times speeding me, because it would be crazy for you to watch this at 1 time speed, right? You can get the jokes twice as fast whenever you put 2 times speed, and then you could just pause it if you want to go back and hear another one, maybe. I want to hear that joke again. Yay! They say find 2 times v. So guess what? You put a 2 in the front of your vector. Guess what you do with that 2? You distribute it. Yes! And you're done. That was the end. Okay, component method, I guess. There we go. Yay! That was so cool. I got a ton of problems. I got a ton of these things. We're just going to be sitting here all day long doing this. Here's another one. And yeah, I kind of do lose patience, I think, on these recordings. So if you have me like just as an online class, I'm not quite this, I don't know, divisive in class. Okay, maybe I am, but I think in class with other humans interacting with me, I just it's fun. We joke and talk and all that kind of stuff. I can like pause for a little bit. I can actually write at like top speed and not have to worry about my handwriting being so terrible because the stylus is just not keeping up with my handwriting. That kind of stuff. I think I rewrote. Oh no. Okay, pause for a second. Look. This is 2 times W and this is V. So notice that my W and my V, they just flipped them on you. Okay, watch out. So guess what you're going to do first? You got to distribute. Yeah, you distribute first. Did you know that? Oh my gosh. Uh, 24. And then you add those together. Feeling like a math rock star. Whoop, whoop. Okay. We've got to get to something more interesting here in a second. This is... well, this is. It just is. Okay. And they say, find the magnitude of 2 times v. So there's a couple ways you can do this. You can actually take that 2 and move it out and then just find magnitude of v, which I don't do, actually. I'm not doing. And so let me show you what I'm going to do. I have magnitude of 2 times v. Oops. So I actually have the magnitude of 4 negative 6. And of course, that means square roots. And yes, I don't have the negative. It cancels anyways. Square root 52 is 2 square root of 13. Okay. Again, there's a lot of math going from here to here that I'm not showing. I used a cool calculator. So I'm telling you, if we were allowed it, man, this Casio 115, it's like a $10 calculator at Walmart, and it can do calculus, man. It's so awesome. It does the square roots, it does Pythagorean theorem, it does pies, and it does imaginary numbers. It does quadratic formula for you. I think it even solves cubes. Like, it is so spectacular. And that's why it's not allowed on exams, unfortunately. But it makes it easier. It makes it look cool. Like, oh man, Chad really knows the square root stuff. Whatever. mean, it's yeah. I could do it, of course. I can do it. It just takes a whole second. I feel like this is becoming more of a commentary than a math lesson. Let's get back to the math. So I got this guy and I got this guy. I'm supposed to subtract them. Remember that this one minus that one, not the other way. And so we have -1, -3, 9, -7. Distribute your negative, so then I actually get -10, and then 2 negatives make a +7. You get a 4 there. Um, 2 square root of 29. Everyone knew that. I'm just copying my notes. It's kind of boring. Okay, next thing. So they're talking about the unit vector. Unit vector. And there's a formula for it. Let me go ahead and give it to you. So my unit vector u is equal to v over magnitude of v. What is a unit vector? It means radius equals 1 or distance equals 1. Okay. It means, yeah, my magnitude is equal to 1, essentially, okay? That's what unit vector is, like unit circle, unit vector. So in this particular problem, they have my v vector is equal to 8i, and that's it. Now, sometimes they're going to be all silly like this. What that means is that it's 8, 0, because where's your j? I don't have a j, so then it's a 0. All right, so then we're trying to find out what the unit vector would be for that. Oh, this is so easy. Just the way we have to do it, it just, okay. Anyways, so I need to find my magnitude of v. So that's the square root of the squares. Just an 8. And so what I actually have is 8, 0, all divided by 8. And so I divide each term by 8. And so I got 8 over 8. And then I got 0 over 8. One 0. Yay. Okay, of course they didn't like that. They want a 1i. So just watch out for them being just that way, okay? It's really their fault. It's not yours. Okay. Next one. It says a little bit more tricky. They say I've got -10i minus 24j. They say find the unit vector for this. Okay. I said more tricky, but in the end, it's not that much worse. You know, I think I know what the problem is that there's not really any time for me to pause here. I'm constantly just writing. I literally don't slow down at all to just... I can't, because what is there to talk about whenever it's just static? I can explain it all as I'm writing, and I just keep writing, and it kind of just gets a little annoying. Anyways, the square root of 676 is actually just a 26, so that's kind of nice. Now, I'm going to take everything I had here, and I'm going to divide it by the 26, and so my unit vector is going to be -10, -24, all over 26. And when you do the math, okay, special triangle, super cool. Okay. Oh, I have a note here. So, yeah, we're done with this one, but I have a note. It says sometimes you'll get radicals. Make sure you rationalize denominators. Basically, sometimes when you get a square root of 676, it might not be the square root of 676. It might be the square root of 675. And now all of a sudden you're going to have a crazy radical in the bottom. And so what do you do in those cases? Well, you rationalize the denominator, and all that other fun stuff that we've been learning forever. Okay. I got to see some light ahead of the tunnel. 1, 2, 3, 4, 5, 6 more problems. Okay, that's a 47. Okay. So magnitude of V is a 10. Theta is 60 degrees. What's your original vector? So I know it's 10 distance at 60 degrees. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There you go. So hey, how do I classify this vector right here? Well, you know it's an x and a y, don't you? And you know that's going to be r cosine theta, r sine theta. And so 10 cosine of 60, 10 sine of 60. That's a half. Square root 3 over 2. Cancel, cancel, cancel. Okay. And of course they want it in component form. That's supposed to be a J. Whew. All right. I mean, I'm really looking at these problems and I'm wondering how useful they are to you. You know, I'm the one that teaches Calculus 3, okay? So I know exactly what you'll see in Calculus 3. And are these things you'll see in Calculus 3? Yeah, actually, they will. Do you have to learn it here in pre-calculus? I mean, gosh, just like Cal 1 and Cal 2 ahead of you, you're totally going to forget about all this stuff. Do you actually need to memorize all the stuff for the next, 3 semesters? No. Because it's so easy, you'll relearn it in Cal 3 in a minute. Heck, if you hadn't had pre-cal, I could still teach it to you in a minute. It's not hard. Is any of this hard? It's not hard. It's just long. Okay. There we go. Oh my goodness. Now, what in the hay is going on here? Well, they want to find the magnitude squared and then the magnitude squared and do it. I'm sure they got a reason for this. I'm sure they do. I just don't know it. So, you know what they want? Magnitude squared is funny. It's like the square root of the squares, and then you're just going to square it. So you actually just get this thing in the end, okay? And same thing here. 2 squared and a 1 squared. That's a 1, by the way. Whoop, there you go. So looking back, oh, wrong, Chad, wrong. That is technically the magnitude of u squared, isn't it? But that's not what they're wanting. Oh, it's okay. I don't mind looking like an idiot. Maybe I should stop talking so much and start just doing my job. So, u plus v is equal to these things. I'm going to add them together. Here we go. -5, 7. Let's do a u minus v. So -7, then -9. -9. Why do I have a positive 9 on my thing here? Oh, no. Sorry, minus 2 negatives make a positive there. Yeah, that's a positive 9. Okay, we're good now. Okay, now let's find the magnitude squared. 5 squared, 7 squared. This is 9 squared, 9 squared. It's actually, I went too far. I went back and forth too much when it was pretty simple to begin with. 9 squared is 81? Oh, times 2. Let's just get the calculator out. My notes are not exactly right. I mean, they're right. It's just not the way I want to talk about it right now. Oh, now my calculator's not wanting to talk to me right. Okay, 162. So then, hey, it says to minus these guys. So I got 74 minus the 162, and I get a negative 88. And there we go. One, two, three, four more problems. Okay, is this one actually an interesting problem? No, it's just one of those problems where they want to get you. Okay. I've always had this fond appreciation for problems that are meant to have it get wrong because of frustration, and then oh, that's what you wanted. You just wanted it that way. Yeah. Okay, let's do that. So I have a vector, and they say find the magnitude. This is my r, and that's my theta. Wow, I haven't done this at all so far. 7 squared, 14 squared. Square root of 245. And so I got 7 square root of 5. But you know what? They type it in. No, you're wrong. No, you're wrong. What did they want? They wanted the decimal. Oh, wow. That is so mean. All right. Well, just prepare yourself, okay? So the arctan, right? That's how we're going to find our theta, is the arctan of y over x. So the arctan of negative 2 is equal to a negative 63.4349. Not yet. That's not the full answer yet. Notice that we have a negative x and a positive y. If you were to graph it, it's up here in quadrant 2. Does that look like a quadrant 2 angle? Nope. Add 180 to it, and you get 116.5651 degrees, and that's what they're finally looking for. Just one of those gotcha problems. They like those, my math lab. Okay, so here's an actual application-y kind, finally. There's a plane going down the runway at 155 miles an hour. Whoa! So let me do a plane coming in hot, okay? There's your plane. And he's coming into the runway, and there's the runway down there. And he's coming in at 155 miles per hour. And the angle at which he's approaching is 4 degrees, not the scale. And they say, find the vector v. Okay, so r cosine theta, r sine theta. That's right, because this is an x and a y, right? So that's all they're wanting, I suppose. So 155 cosine of, now be careful here. I'm just disappointed in my handwriting. It's abysmal. And I know I don't have great handwriting in class either, but anyways. What do I put in there? And you would automatically say, well, 4 degrees. You're kind of close. Look, take that vector and keep going. If this is 0 degrees, what is this right here? Negative 4 degrees. Isn't that interesting? Yeah, negative 4. You could also go and put in the other one over there. Actually, you know what's interesting? Yeah, this is, no, you can't put in the other one. You need to put in just the negative 4. Why is that? Because this is the vector right here. Again, if this is the origin right there, isn't that going to be in quadrant 4? Shouldn't I get a positive x and a negative y? And watch, when I put that into the calculator, I got 154.62 and then a negative 10.81. Positive, negative, quadrant 4. Okay. Yes. Good. 2 problems left. Okay. And at this point, it's just so hard to keep having like that. Just it's so hard to keep going, man. When you've done so much already and you just want to stop. And I know you might want to as well because this is near the end of your section anyways. They have a lot of different components here. A lot of different vector components. Oops. Wrong way. Okay. And they say, what's the resultant force? Okay. Resultant force is so important in engineering, in physics, and even some calculus 3. This kind of problem is going to be something you do a lot. And it's great. My math lab does not do a great job of it, unfortunately. And that's fine. It's like the end of this section, so they're kind of saying who cares anyways. It's kind of sad. But you know what? That's fine. We're just going to do it, and it'll be great. How do we find the resultant force? And what's going on here? Imagine that we're pulling at this object in 4 different ways. Kind of like tug of war, you know? But there's 4 different lines and all that stuff. Well, where is the center going to be moving? What's the ultimate result of all these things? In my opinion, it kind of looks like it'll end up going this way a tiny bit, right? Because he's pulling, they're kind of counteracting each other. And they're pulling, but they're pulling stronger than these two in a way, so they're kind of like just barely shifting it this way. That's just my thoughts. I don't know. So what we need to do is put all the math together and see, okay? How do we do that? You take all of your vectors and you add them all together. And I wrote mine like side by side on my notes, but I'm going to do it vertically because we are much better at adding things vertically like this. So what's all my resultant force here and there? I have -6. Wait. I messed up something. Hold on. Look, -3, 0. 0, -3. Ugh, so annoying. I'll blame my dyslexia on that. How about that? Can I do that? Can I just blame myself, but then don't take the blame for it? So I got 0 out of it right here. I got 0. And when you do all this stuff here, I got a -2. And so that's your answer, is 0, -2. But of course, my math lab says, no, we don't want that. And so they're going to want it like this. So that's a resultant force. That's fine. Now, part B says we want to make it in equilibrium. Oh, don't ask me to spell this. Okay, equilibrium. There you go. How do you make it into equilibrium? Well, what they're saying is that we should use the opposite. What's the opposite of this guy? Is going to be a positive 2J. Oh, wow. Really? Yes, really. Okay, so if you look back here, the resultant was actually, it was going straight down a tiny bit. I thought it was going this way, but they cancel at each other sideways, and it's going just straight down a little bit. So that's a resultant. To make equilibrium, we would need this. So we would need one last rope. Someone's going to pull here at 0, 2, and now it's a total equilibrium, okay? That's kind of what they're asking for. They're like, hey, if we added a 5th person doing the tug-of-war thing, how would we make that stand still? There you go. Last problem is a GeoGebra problem, okay? So GeoGebra number 26 on your homework. Now, Uh, I think this is one of those confusing graph things, and you have to move things around. I'm just going to draw what I got and do the best I can here. So I got a u vector, 1, 2, 3, 4. And there's a vector right here. You know what? I'm going to use a different color. That way, for sure, we're going to try not to do confusingness. So u is equal to -4, comma 0. Okay, awesome. And then I have a v. Again, I don't remember everything perfectly, so here, let's do this. No, that looks too much like red. Let's just do a green. So we have a v, which is going down right here, and v is equal to -1, -1. Okay, cool. And then they say that w is equal to u plus v, and you might have to graph it and like drag something around. But we got to do the math first. So I'm going to take these two and add them. Okay, so that's my result. And so what you need to do is like drag one out over here somewhere. I don't know. It's going to be something like that at -5, comma -1. And check, correct, great, done, etc. Okay, we're done. That's it. Thank you. Good day.